Substitution on it. I think I can walk you through it, but we have to start our little session right now. It's not quite as easy as just you're on the right track. But okay. All right, let's go ahead and get started. So today we're just going to kind of cover first, second derivative test. So we did all of this long ago, but let's see what we remember. So for the first one, for the first derivative test, okay, f is increasing when f prime is positive. F is decreasing when f prime is negative. Critical numbers are where the derivative is 0. And then how do I know that I've found a max? How does f prime have to change sign? Plus to minus versus a min would be -2 plus. Okay, so let's go ahead and do the first one here. So it says, where is f increasing? Then that tells me I want the first derivative and I need it to come out positive. So let's take the derivative of this guy. F would go to f prime of x. And what is the derivative of 300x minus x cubed?
300 minus.
Okay, then from there, my critical numbers, I set that equal to 0. And then Suhaila, you're looking for the one on the left for today's. What can I take out of both of those? 30. So that's going to leave me with 100 minus x squared. Now, don't just flip the order around on this. If you're going to do that, you can, but you need to GCF a negative out. So I'm not going to do that. I'm just going to factor it in the order that it's given. What's the square root of 100? So it'll be 10 plus x and 10 minus x. And then from there, what are my two critical numbers? Negative 10 and 10. Very good. Okay, remember, once you have your critical numbers, you're going to put them on a number line. And then you're just looking for the direction that the signs will change. So let's put -10 here, +10 here. For any number that I want bigger than 10, if I do 3 is obviously positive, 10 plus 10 is positive, and then bigger than 10, so let's say 12. What would 10 minus 12 come out to be? Positive. But for this piece, it would be negative. Between them, let's pick 0. 10 plus 0, positive. 10 minus 0. So 2 positives, keep it positive. And then on the far left, less than -10, let's say we pick -12. 10 plus -12 is negative. What about 10 minus -12? Positive, and a minus times a positive makes a minus. So that means my graph goes downhill, uphill, downhill. Okay, remember, first derivative test tells you increasing, decreasing, and then your mins and maxes. So where is f increasing? It'd be -10 to 10, answer choice B. Okay, go ahead and set up the next one. Okay, we see that we want a maximum. So what are you going to do first? Take the derivative. So my x cubed will go to a what? Okay, 3x squared plus next term. Yep, minus. What happens to the 4? 0. Okay. 0 equals, I see all of those can divide by 3, so I'm going to pull that out. That gives me a regular x squared. 6 divided by 3 is now a 2x minus 3. So I need numbers that will times to 3 and add to 2. So what's the only way to times to 3? 3 and 1. And then I have to think about, if I want my 2 in the middle to come out as a positive, I need to make sure my 3 takes the plus and my 1 takes the minus. Okay, from here, we have x equals -3 and +1 for my critical numbers. Okay, go ahead and set up your line chart. Pick a number bigger than 1 say we just pick 2 to keep it easy. 2 minus 1, how does it come out? 2 plus 3. 2 positives make a positive. Between them, let's say I pick 0. 0 minus 1 is 0 plus 3 is overall negative. And then for my last one, let's say this is like a -4. -4 plus 3 is negative. -4 minus 1 is negative. But when I multiply 2 negatives, what do I get? Positive. Very good. So then I know that it goes up, down, up. Which of those would be a maximum then? Okay, now this is really important, okay, because that is not the right answer. Okay, -3 is a relative maximum because f prime changes from plus to minus. So if they said, where do I have a relative max? This would be the right answer. But what is it asking me for? Absolute is where you have to do a candidates chart and see if that's really the biggest number or if another number is bigger. So for absolute, you need to do a candidates chart. What are the 2 types of things that need to go in the candidates chart? Endpoint. So we're only looking from the closed interval from -4 to 2. And then the other thing would be any relative winners. Okay, now I had 2. I had a -3 and a 1. But if 1 is a minimum, you know it's not going to win. So you can just kind of leave it out of the chart. So -3 needs to go into the chart. Okay, but 1, I can leave it out because if it's a minimum, it's not going to be the overall biggest. What do I plug these into? Original equation. Plug into original. So my original equation is x3 plus 3x squared minus 9x plus 4. Okay, so just to make this process short and sweet, I'm going to put it in the calculator. So x to the 3 plus 3x squared minus 9x minus 4. In my chart, I see that at -4, the y value is 16. At -3, it's a 23. And at 2, it's a -2. Okay, but you would probably have to plug those in since it's just a polynomial by hand. Okay, then from there, which those numbers is the biggest? So 23 is the absolute max. It occurs at -3. But remember, for absolute, you have to actually check that y value. Okay? All right, turn the page. So first derivative test is mins and maxes, increasing, decreasing. Does anybody remember what the second derivative test does? The concavity or the curve, very good. So up here at the top, for a second derivative, f is concave up when f double prime is positive. Concave down when f double prime is negative. Okay, and remember your points of inflection are where f double prime changes sign. Remember, for a point of inflection, it doesn't matter if it goes plus to minus or minus to plus, it counts either way. Okay, so take your equation here. Go ahead and take the second derivative. Remember, that means you're taking the derivative once and then you're taking it a second time. So f prime of x would be what? Oh, oops, I skipped one. Sorry, this one. Okay, 15x to the 4. Are these the same? No. Plus. And that's y prime. Okay, then for my point of inflection, we're going to need to do one more derivative. So we can call that y double prime. 4 times 15 is 60x cubed plus 120x squared. Okay, then remember, we're going to set that equal to 0 and look for r. Technically, they're not critical numbers because it's the second derivative, but they kind of are. So take out a 60x squared. What's going to be left behind? X plus 2. And then from there, that means that the points that I'm interested in would be -2 from the parentheses. And then what would I do for the X on the outside? 0, very good. Set up your number line. Make sure you put them in the correct order. So 0 would be on the right, -2 is a little bit less than that. And then go ahead and check your signs. Remember, you're plugging in to this to see how it's going to come out. What will be true about the 60x² part? What will that always come out to be? Positive. If it's squared, there's no way this can come out negative, so I can almost just ignore it. Say, okay, well, bigger than 0, if I add 2 to it, it's positive. Less than 0, if I add 2 to it, it's going to be positive. But once I go past -2, let's say I pick like -3, then if I only add 2, that won't be enough. So my graph would be concave down, up, up. So my point of inflection would only be at -2. So typically, if you get a term that has a squared on it, it's not going to have a sign change around it, because when you square something, it always comes out to be the same sign. Okay, go ahead and set up the next one for me. Or actually, let's skip that one. Let's go to the third one. So it says, on which of the following intervals, so we're skipping this guy, okay, is f prime positive and decreasing? So let's think about what that means. I want f prime to be positive, and I want f prime to be decreasing. If f prime is positive, is that a first derivative test or a second derivative test? First. And if I want f prime to be decreasing, that means f prime needs to have a negative slope. So that's actually a second derivative test. Okay, so think about it. If f prime is decreasing, that means f prime has a negative slope, which means it's really f double prime that needs to be negative. So this one is a first derivative test. This one is a second derivative test. Okay. So let's do it. Go ahead and take your first derivative. So if it's x3 minus 3x², what's the derivative of that? Okay. We can take a 3x out of there. That gives me an x minus 2. Which means that my critical numbers are going to be 0 and 2. Now, I'm planning on stacking my derivative tests on top of each other. So if you want to kind of do it over here to the side, okay, 0 and 2. Pick a number bigger than 2. Let's pick maybe 3. 3 times 3 is positive. 3 minus 2 is positive. What about between them? 1 is good. 3 times 1 is positive, but 1 minus 2 is negative. And then if I go past 0 to the negatives, okay, 3 times the negative is negative. Negative minus 2 is negative, but what happens when you multiply 2 negatives? Positive. So it's going to be increasing, decreasing, increasing. Now let's do our second derivative. Remember, you want to take the derivative of it from here. Okay, otherwise you would have to do product rule on that, and that would be pointless. What's the derivative of this guy? Minus 6 equal to 0. I can pull a 6 out. So I have just an x minus 1, which means my point of interest would be 1. Go ahead and mark it on your number line here for your second derivative. Okay, make sure they do have to be kind of lined up with each other. So make sure that your 1 hits between where the 0 and the 2 are. Bigger than 1, let's say I pick 2. What's 2 minus 1 here? Positive, but less than 1, let's say I pick 0. 0 minus 1 comes out negative. So I'm concave down, concave up. Okay, then remember, we want F prime to be in positive, so that'd be here and here. But I want F double prime to be negative, that would be here. So where would my overlap be? Negative infinity to 0. Good. Okay. But if you're looking for both, that's where a double line test can kind of help with that. Make sense? All right, go ahead and turn the page. Next one, let's do the one down there at the bottom. So we have an equation, f of x equals x squared e to the x. Okay, we are asked to find where f is decreasing. First question, are we doing a first derivative test or a second derivative test if we want to know decreasing? First, second would be concavity, right? So we're going to do a first derivative test, which means that I need to take f prime of x. Okay, but then I notice that my f of x is x squared e to the x. What rule am I going to need to take the derivative of that? Super throwback. Starts with a P, product rule, because it's two things times together, right? So let's review how to do product rule. You're going to pick your u and your v. Remember, these should be the pieces that are multiplied together. So my u is an x squared. My v is an e to the x. Then remember, I take the derivative of those two pieces separately. So if u is an x squared, what's u prime? V is an e to the x, what's v prime? E to the x again. And then remember, for product rule, you do the diagonals added together. So my f prime is going to be x squared e to the x plus, for product rule, and then 2x e to the x. What's the next step in derivative test? I take the derivative, set it equal to 0. So I see that both of these have an e to the x. So let's go ahead and pull that out. Do they also both have anything else? They also both have an x. So I'm going to take that out next because I forgot. So my e to the x comes out, and then I notice, oh, this can factor again. Let me pull that x out. So I have e to the x, a regular x, and then an x plus 2.
Good morning, Eagle. Today is Thursday.
Okay,
April
from
24th.
here, what are my critical numbers?
Please stand for the pledge.
-2 and what?
I pledge allegiance
0,
to the
correct.
flag of the
Now,
United States
for
of
the
America,
e to the
and
x,
to the republic
you're not going to get an
which stands
extra
one
answer for that.
nation,
E to the x
under
never
God,
crosses
indivisible,
0, so that's why you
with
don't get a
liberty
third
and
answer.
justice for all.
Okay, set up your number line.
Flag. I pledge allegiance to the
0, -2.
one state under God.
And then remember, if we want decreasing, we're looking for the pockets of the number line that come out negative. So let's say we pick bigger than 0, let's pick a 1. 1 plus 2, positive. 1, positive. What is E always?
Don't miss out on the
Positive.
fun filled
So
day.
overall, plus.
Tickets and meal options are available
Okay.
and payment is due.
And then if you
today
want to put a
on
little
the
note here,
Any
the
questions,
e to the
please
x
address
graph
11. The RHS
is
shows
always
boosting clothing drive ending tomorrow.
positive.
Donate gently used clothes, shoes,
Okay.
hats.
So really, this term, even if you plug in a negative into it, it would still be positive.
Or
over
any
it.
value in-
What's my middle section going to come out to be?
For any senior who graduated from Spring Valley.
So if I do
Elementary or
-1, -1 plus 2 is positive, but what about this x?
Apply by Monday, April.
Would come out
28th.
negative, which would make it negative over.
Don't miss the airplane toss event. Join us.
And then if I go all the way far left, both of these will come out negative, but when I times them together, it'll be positive. So I want decreasing, then I want -2 till.
Desperado Hopefuls Tryout Week
Okay.
will run from April 29th to May 3rd. To try out.
All right.
Pick up a tryout.
Go ahead and turn the page. Let's do the bottom one there.
Junior parents are invited to attend the annual College and Career Prep Night at RHS. on May
Okay, so you have a graph of f.
in the library from 6 to 7:30 p.m.
Okay, so this is f of x.
Junior parents. During
And
the
they
meeting,
are
parents
asking you to
must
compare
schedule
3 things.
Please
f
remind
of
parents
1,
to check their email
f
to
prime of 1, and f double prime of 1. So if this is a graph of f, what would f of 1 be?
parts to hospitalized children.
It would be the Y value, which in this case would be zero.
Up to 5 cards for 5 hours.
Okay, so I'm gonna put down here, F of one is.
Drop your cards off in the library.
If I'm looking at F
So don't.
and I want F prime, what would F prime be in this graph? What feature? Slope, very good. And if I look at one, what is my slope? You can't tell me the exact number, but is it positive or negative? My slope is positive, so I'm gonna put F prime of one is positive. What feature would F double prime be? Starts with a C, concavity. And if I'm looking at the concavity at one, how is it bent? Is it up like a cup or down like a frown? Down like a frown means F double prime has to be negative. And then when you put those in order, remember the alligators eat towards the bigger number. So you want the positive to be the biggest, 0 to be in the middle, and then the negative to be the smallest. So it need to be F double prime comes first, then regular F comes second, and then F prime comes third. Does that make sense? So what answer are we looking for? D. Good job. All right, let's go ahead and turn the page. Let's see if we can do one more. Okay, we want a positive first derivative and a negative second derivative. Okay, I want you to draw me an equate or a graph, little snip of a graph that looks like that. Positive first derivative, negative second derivative. What does positive first derivative mean?
Positive slope.
Positive slope, very good. So I need it to go uphill. And then negative second derivative means what?
Concave down.
Concave down. So I'm gonna put CCD. So draw me a graph that looks like that. Uphill, concave down, it has to look like that. Is your graph getting steeper or flatter? It's getting, so it starts off pretty steep, but then what happens? It's getting flatter. Then remember, in this case, you want your jumps in the table to get smaller each time, but they have to be increasing. Which of these graphs are your Y's not even getting bigger? C and D and E. All three of those are out because they're not even going the right way. If I want a positive first derivative, my numbers have to be getting bigger. Okay, then my jumps have to be getting smaller. So from 7 to 9, that's a +2 gap. 9 to 12 is a 3 gap. 12 to 16 is a 4 gap. That graph would be getting steeper as your slopes are getting bigger. Versus on this graph, I go up 4, then how many? Then 2. This is going to be your flatter match. Does that make sense? Okay. That's all we have time for. It's 11:02. Pull out your sheet. Make sure you write the name of your study session. So it was, you can just put derivative tests. You don't have to put particle motion. Okay, and then I'll come around and sign it. Okay, they don't have to be in order. So if you're going to go back and do last times, you don't have to put that first. It doesn't matter. Okay, good job.